Hey everyone, today we're going to talk about describing features of functions, and we're going to be using derivatives to help us do this. Now this first page in the notes, we're actually going to save this to go through in class tomorrow. That'll help us pull the ideas together. In this video we're really going to kind of go through some vocab and some of the processes we do to find out these features of functions. So let's go ahead and skip this page and we'll look at the next one. So the first vocab word we have is the idea of knowing when a function is increasing. So by increasing, we know a function is increasing. So f is increasing. So if I have a function f is increasing when it has a positive slope. So, for example, if I look at my first graph, sorry, this is adjusting. Here we go. I know it's going to be increasing from here to here. So let's say f is increasing on the interval, let's see, from negative infinity to 0. And then it's increasing again on this interval when it has a positive slope. So that looks like from 2 to 3. So I'm increasing wherever I have a positive slope. Now, that's when we're looking at the graph of f. What you're going to see coming up in this chapter is that a lot of times we're going to be given the graph of f prime, and we're going to be asked questions about f. So we'll be using the graph of f prime to analyze our original function f. So I have to know what I'm looking for if I'm given the graph of f prime. So here's what I want to point out. When we talk about f having a positive slope here, we know that the derivative gives us that slope. So really we're looking for when is f prime greater than 0. So f is increasing when it has a positive slope or when f prime is greater than 0. So if I look now on my graph of f prime, I know that f is increasing whenever f prime is greater than 0, which is the same as saying wherever f prime is above the x-axis. And let me see if you can actually see that. Okay. So when I look at f prime, I know f prime is greater than 0. It's above the x-axis here and here. So I would say, now again, I'm looking at f prime, but I'm still analyzing f. So I would say f is increasing on the intervals from negative infinity to 0. And let's see, it still looks like between 2 and 3. And now to justify that, I would say because f prime is greater than 0. That's how I justify that I'm increasing on those intervals. Now, let's see how we would do this if we're given the actual function. So in this case, I'm given the function for f, and I have to find out when it's increasing. Now again, we're going to use this idea here that we're increasing when the derivative is greater than 0. So our first step is to find the derivative. So we've got 6x squared minus 12x, and I want to know when that's equal to 0. So I'm going to go ahead and I'm going to factor out a 6x, and I get x minus 2. So that means I'm equal to 0 when x is equal to 0 or x is equal to 2. So now we've got some values here, and so now we need to use those to help us find our intervals where we're increasing. So here's what we do. We set up a table. So f prime of x. Now in this case, I know my domain here is going to go from negative infinity to infinity, and I'm going to put in these values in between. So when x is 0, when x is 2, and then again, the end of my domain would be infinity. And I'm going to test values in each piece piece here. So for example, between 0 and negative infinity, I would test maybe, let's say, -1. The easiest way to test this is I'm going to plug it in to my factored form of the derivative. So if I plug in a -1, I get 6 times -1 is -1. -1 times -2 is minus -2 is a -3. If I have a negative times a negative, I know that's going to give me a positive value of my first derivative. So again, that was when I plugged in a -1. And you don't need to write that, but I'm just, in case you want to go back, we plugged in a -1 into our first derivative, and we knew that a negative times a negative would give us a positive value there. Now I'm going to test a value in between 0 and 2, so maybe I'm going to test 1. If I plug in a +1, I have a positive, 6 times 1 is positive, 1 minus 2 is negative, so a positive times a negative tells me my derivative is negative on that interval. And then for my last part here, I'm just going to plug in 3. So if I plug 3 into my first derivative, I get a positive number here. 3 minus 2 is still going to be positive, so a positive times a positive gives me a plus. So we said we're looking for the intervals where f prime is greater than 0. I know that happens here and here, where my first derivative is positive. So again, we would say f is increasing on the intervals from -infinity to 0 and 2. In this case, we'd say, let's see, 2 to infinity, because f prime of x is greater than 0. So I guess going back here, this should actually be, assuming this continues, I'm going to change this here from 2 to infinity. But the big idea we want you to get here is being able to analyze the graph of f, how to find out information about f looking at the graph of f prime, and then how do we do that if we have a function. So we're going to take the same idea, but now we're going to talk about when we're decreasing. So decreasing, we would say the function f is decreasing when f has a negative slope and now same idea applies. When we're talking about the slope, we're actually talking about that derivative. So now it's when f prime is less than 0, or where f prime is below the x-axis. So we're going to look at these same ideas again. So if I am given the graph of f, I need to know where f has a negative slope. So here I'm looking over this interval. So f is decreasing on the interval from, let's see, it looks like 0 to 2. And I also have a negative slope here. So we would say it looks like from 3, and assuming this goes on, 3 to infinity. Now, in the next graph, I'm looking at the graph of f prime. We said we know that the original function f is decreasing when f prime is less than 0. So when f prime is below the x-axis. So that's going to be right here. Now again, in my statement, I'm still talking about f. I know that f is decreasing on the interval, in this case, from 0, it looks like 0 to 2. And our justification is because f prime of x is less than 0. Okay, and then we have the same idea here of finding this if we're given the original function. Now in this case, we actually use the same function up above, so we don't need to do this work. I'm going to copy though this table that we had. So it was the same function. We took the derivative, we set it equal to 0, we solved for our x values, and then we set up our table. And so we tested some points in each interval. Oops. So now I'm looking for where f prime is less than 0 for when it's negative. That happens right here. So again, we would say that f is decreasing on the interval from 0 to 2. And again, our justification is because f prime of x is less than 0. Okay, so that's the idea of increasing and decreasing. So let's go ahead onto the next page and pick up a few more vocabulary words here. Now, we have these things that you'll see called critical points. And the critical points are points where f prime of x is equal to 0 or is undefined. And these are critical points because they're critical to helping us find features of the graphs. And so we'll make a connection here in a second to the work we've already done with increasing or decreasing. So let's go ahead and look at the graphs. If I'm looking at the graph of f of x, I know my slope is going to be 0. Like if I imagine my tangent here, that's going to happen here. My slope is going to be 0 at that value. We have what we call a horizontal tangent, and we're going to get to that in a second. I'm going to have a slope of 0 down here. And now if I think of a derivative, because I've got this kind of corner cusp point here, I'm going to be undefined here. So we would say f of x has critical points at, let's see, x equals 0 and 2, and I'm going to say f prime is equal to 0. And it has one at x equals 3, and I'm going to say f prime is undefined. Now, if I'm given the graph of f prime of x, right, I'm looking for where f prime of x is equal to 0. So in this case, I'm looking for the zeros of f prime. F prime of x is equal to 0 here and here. So in this case, and there's no points where that's undefined. I'm defined for every point here. So in this case, I would say that f has critical points at x equals 0 and 2 because f prime of x is equal to 0. Now, if we have a function, what the work we already did to find where we were increasing and decreasing is the same work. We actually already found critical points, right? We said our critical points are where f prime of x is equal to 0 or undefined. So our derivative here is going to be f prime of x equals 6x squared minus 12x, and we would set that at equal to 0. Now in this case, there are no points where that first derivative is undefined, so we don't have to worry about that. So we would just go ahead and solve and find out where it's equal to 0. And we would get x equals 0 and 2. And like I mentioned, we already did that work back on page 1. So these points were critical in helping us determine the intervals where we were increasing and decreasing. We just hadn't given them that name yet. So here we would say f of x has critical points at x equals 0 and 2 because f prime of x is equal to 0. Now, all this justification I'm doing with writing because and giving that reason, you want to make sure you're doing that every time. That's a big part of the AP exam, is knowing how to appropriately justify your answers. So now I know this video is getting a little long, so hang in with me just for a couple minutes. So for critical points, we said we find those where the derivative is 0 or undefined. When we're talking about horizontal tangent lines, that's just going to be where f prime of x is equal to 0. So in this case, we have horizontal tangents. That tangent is going to have a slope of 0 here and here. So we would say it has horizontal tangents at x equals 0 and 2. Excuse me. And again, that's because f prime of x is equal to 0. In this case, it's actually going to be the same as the above because there were no points where it had a derivative that's undefined, but we know that derivative is 0 here and here. So we would say f of x has horizontal tangents at x equals 0 and 2, and again, it's because f prime of x is equal to 0. And then again, we won't solve this again, but we know to find a horizontal tangent, we would have taken the derivative and set it equal to 0. We know that was at x equals 0 and 2, so again, we would say f of x has horizontal tangents at x equals 0 and 2 because f prime of x is equal to 0. So there's two big takeaways I want you to have. One is just the vocabulary, these 4 words, increasing, decreasing, critical points, and horizontal tangents. And the other thing I want you to make sure we're all clear on is even when we're looking at the graph of f prime of x, we're always analyzing the function. So it's going to be really important as we go through to make sure you know, do you have the graph of f? Do you have the graph of f prime? And which function do you have? Because sometimes you'll be given the function of f prime, but we're always using that information to analyze what's going on with f. All right, so tomorrow in class we'll go over the first page of the notes, and then you'll have time to practice with this. All right, have a good night.